So, welcome, students, and today we will start a new chapter, and the name of the new chapter will be pre calculus. Okay, I know in the book that is not what is given, but I would like to call the name of the chapter pre calculus. And what calculus or what the thing is, we'll come to know by time. So, now let us see what is it. For that, let us go back to something that you studied way back. I think you studied this in 7th or 8th standard, and that is about I'm sorry, wrong spelling. Speed is equal to distance by time. Um, I'm sure that you have already studied this. Now, and you also studied about graphs, and you studied about plotting distance versus time graph, and then you plotted this. You did all this. You did all this, and you also found out how to find the slope, the different change in y divided by change in x, the change in y divided by change in x. You all studied that already. Now, what I suppose this is a straight line. It's a very smooth driving, very smooth driving. A good driver is driving it probably. But suppose it is okay. By the way, the slope gives you the velocity. Of course, you know that slope is change in distance by change in time. So basically, distance by time, and that gives you velocity. Okay, I know that distance velocity is technically velocity is displacement by time, but displacement is distance also. I know there's a difference, but practically displacement is distance itself. So therefore, you know displacement is also distance. So therefore, slope basically gives you the velocity or speed. Okay, so I'm not going to much technical terms because physics is not my topic. Tina sir will take care of that. As of now, you understand what I mean. Okay, so this is you could take slope in different points. This is another slope. Anyways, suppose it was not a that good driver. Suppose it was whom should I take? Hmm. Suppose it was Usmida who was driving. It was not that smooth. It was kind of like this. And what happened is, here also I can take the slope, and suppose this is the slope that I have taken. But there's a problem here, and to explain that problem, you need to go back, look at our previous graph. Here, this was our slope. Okay, suppose I'm keeping this slope like this. I can keep this anywhere at the graph. I can keep this anywhere at the graph, and it will be the same. It will be the same because you can see it is the same. It touches every point. But suppose I'm doing the same thing with the other graph. What happens? This is my slope. If I'm putting the slope here, almost touching, putting the slope here, oh man, no, it doesn't touch. If I'm keeping the slope here, keeping the slope here, no way at all. So you get it. The slope, that means I need to change the way I draw the slope, or basically the slope is changing. The slope is a variable. So you see that there's a difference now. So how will I find velocity? How will I find exact velocities or exact speeds? How will I find it? The slope is changing, and my sir taught me only to find velocity. My sir taught me to find velocity only by taking slope. How will I ever find velocity now? And we see that the velocity also keeps on changing, because here we see the car is slowly moving, then it is moving fast, and then it is increasing its, it's not increasing its speed. The speed is same here, the speed is same, and here the speed decreases and it goes. So what do we do? And to solve this issue, to get very precise measurements of speed from the graph itself, I'm introducing to you a thing called tangent. And I know that it is not a new thing to you, but there is something new about tangent that what we are going to learn. And tangent, that word is not an English word. It doesn't come from the English language. It is now used in English, but it actually comes from the language Latin. It comes from the Latin language. And in the Latin language, the word tangent means touching. So it is actually, that is the meaning of and it is from this word that we get English words like tangible, and it's all comes from this word. Now, by the way, in trigonometry, when I was teaching in trigonometry, I brought the concept of unit circle. And unit circle means circle with radius 1. And I'm taking this radius, okay, this blue color radius, and that is, of course, this is a unit circle, so this radius is 1. Now, what do you tangent? You already learned about tangent. Tangent of x is O by A, opposite side by adjacent side. Now, suppose the adjacent side is 1. Suppose the adjacent side is 1, then I can say tan of x is equal to O. I can say that. So now this side is 1. This blue line is 1. Now, if I am drawing a right 90 degree, if I am taking 90 degree, and if I am drawing a perpendicular, I can see that I get a triangle here. See, if you look at this triangle, I can say that this because the angle is here, x, this is the adjacent side, and because when adjacent side is equal to 1, tan x is O, tan of the x's tangent is opposite side. So I can say that this is the tangent, this line is the tangent, and we learned that tangent means touching. And why we used why tangent, why the touching, why that word came to be used for this is because this line, this specific line, touches the circle at only one point. You can look carefully. It properly touches the circle at only one point. And that is why it is called tangent, because it just touches the circle. It just touches that curve. And that is why it is called tangent. Okay, that is only to explain what I just showed that to bring you to an understanding about how trigonometry is connected with all this. It is not a word the same. It is not the same word with a different meaning. It is the same word with the same meaning, but we are expanding. We are expanding its application, I would say. Okay. Anyways, now let me go take a more weirder driver. So suppose this is the graph. A very bad driving, I guess. Okay, anyways, I can take slope at these 2 points, and I can draw a line, because yeah, and then I can take velocity or the speed. Now, this will not be accurate. No, it will not at all be accurate. Why? Why? Because see, between these 2 points, that is here, there is a change in the speed. You see, because here there is a small change happening, so it is not accurate. So if this is my ds, if I call ds is my change in distance, because this is my distance, y-axis is my distance. So this is my small change in distance. This is the change here, ds. And if I call dt the change in time, to get more accurate, very accurate velocities, I need to decrease this time. If see, yeah, I'll show you. Look at this. Suppose I decrease the time, what happens? I get more accurate velocity. Suppose I decrease the time again, I get more accurate velocity. Suppose I decrease the time again, I get more accurate velocity. Suppose I decrease the time again, it is very difficult to see now, right? I get very accurate velocity. Even at that curve, even at that turn, I get that very accurate velocity. Suppose I decrease the time again, now it is very difficult even to see the graph, right? here, if the dt is just very small, I'm getting very accurate velocity, see. And if you look at this line, this line is like tangent. Why? This line touches the graph at only one point. So what I did was I took dt, the change in time, dt, I made that value smaller, smaller, smaller to a very small value, and this was my slope. My slope was ds by dt, that is change in distance by change in time. I took this change in time and I made it smaller and smaller and smaller and smaller until it almost reached 0. I cannot make it equal to 0 because equal to 0 means there is no change. Equal to 0 means there is no change, and that is not possible because to calculate velocity we need change in time. To calculate velocity we need change in time. At a given time, the car is always like this. It's like taking a photo. The car doesn't move. Within a period of time, how much the car moves, that is how we get velocity. So I take very small values, 0.1, maybe 0.01, maybe 0.001 or 0.0001. I can take whichever value I want that can approach 0, exactly approaching to 0, but not equal to 0, approaching 0. And this approaching I can also call with another word, same meaning, and that is called limiting. Limiting to 0. I'm taking 0 as my limit value, but I'm not reaching 0. I'm just keeping 0 as my limit value, but I'm going very, very, very close to 0. And this not only it need not just be 0, it could be to any value, and that limiting to any value is called limits. And this is what you see in your book, limits. You see the topic limits in your book in chapter 13, if I'm right, and that this is the topic limits. Basically this is the word limits is. Then when we limit that small the denominator, when we limit that to 0, then from that topic we get the topic differentiation. But here now we'll be focusing on limits in the beginning, then we'll go to differentiation. By the way, in the distance time graph I need to limit dt to 0. I need to make dt approach 0 to find the accurate velocity. But for other functions, this is for distance time, for other functions I could limit it to any other value. We'll see that, we'll come to see that. But for now, just understand that this is what the whole topic that you're going to study is all about. Okay, so the next video we will study a little more about limits. Thank you.